Welcome to the further demonstration of prepaid energy meter by using PIC Microcontroller. So here the main operation of this project is we are going to set the units limitation from this keypad. So we can set the increase the units maximum limits and we can decrement that. And once you set the limits, then automatically the system will on the relay whenever the so-called balance is greater than the 0. And when we connect the load, we are getting the input from this optocoupler from the energy meter, this LED pulses. So when the kWh reading increases, the balance will be reduces. When it is 0, automatically the relay will be isolated the supply to the load from the input section. And again, if you want to increment recharge that, then again reset the system, again place minus to set the unit limitation and set that. Then again, if it is greater than 0, it relay on, and the load consuming the power while the kWh increases, balance decreases. So whenever the balance is less than the 1 unit, then we are providing the audible alert to the user to intimate him you are going to be balance is going to be end. So this is the main operation of the project, and we are providing 230 volts AC inputs to this energy meter and to this regulated power supply board. So regulated power supply board has the 4 stages: transformation, rectification, filtration and regulation. So after these 4 stages, we will get the 5 volts DC output. So here it will take the transformation to step down, rectification to convert AC to pulsating DC, filtration to remove the pulses to make the DC a smoother one, and regulation to take the 12 volts DC input and provide as a 5 volts DC output. Once we provide that 5 volts here, the motherboard will start reading input from the input modules like keypad first, and after you set that, then again it read the input from the optocoupler, that is PC817. The main purpose of this optocoupler in our project is we can directly interface the LED to the microcontroller. Just the purpose of this optocoupler is to get the pulse input from the LED, and same pulses will be given to the our microcontroller. So if we connect the LED directly to the controller, if is any short circuit occurred inside the energy meter, so then the microcontroller may get damaged. In order to protect our main motherboard, which is the brain of the project, so we place the PC817 optocoupler as a driver between these two, right? So if any short circuit occurred, then only IC, the small IC will get damaged, so then we can replace that easily, right? And now next the relay, right? Coming to the connections, we have interfaced these 3 push buttons to the C3 D0 D1 and LCD H pin number B2 to B7 and relay H D7, and buzzer is connected at the D2, and our optocoupler is connected to the A4 pin. So they are the interfacing connections. So let us see the demonstration. Connect the bulb. Better to use a 100 watts or 200 watts load, so that we can the load will be consumed more and we'll get the faster response. So now set the units. So press and hold. So keep on units increments. There is a limitation for the maximum units and decrements. Okay, let us place the 2. Now when you set that, so setting was done. Now the relay gets switched on. Right. Okay, so when the balance is less than the 1, then automatically we will get the audible alerts from this buzzer as alert to the user, right? And when it is 0, automatically the bulb will be switched off. Right, 0. Okay, and now if you want to recharge again, reset the system. So 1 unit only I am setting now. Recharge.